Hello and welcome to this lesson on alcohols. In today's lesson, we will understand what an alcohol is and we will explore the structure and general formula of alcohols. Then we will learn to identify and name different alcohols. Finally, we will understand key physical properties of alcohols. So far, we've discussed alkanes and alkenes, two types of hydrocarbons. Alkanes are saturated hydrocarbons with single bonds, while alkenes are unsaturated hydrocarbons with at least one double bond. Building on this foundation, today's lesson will introduce you to alcohols, another important homologous series. Understanding alcohols will help you gain a deeper understanding of organic compounds and their various applications. Let's get started! Alcohols are a homologous series of organic compounds. The key feature of alcohols is that they contain an OH group, often referred to as a hydroxyl group, which is attached to a carbon atom in the molecule. This OH group is responsible for many of the properties and reactivity of alcohols. Unlike alkanes and alkenes, alcohols are not purely hydrocarbons because they also contain oxygen atoms in addition to carbon and hydrogen. The OH group is what defines alcohols and gives them distinct chemical properties like higher solubility in water compared to alkanes or alkenes. The general formula for alcohols is CnH2n plus 1OH, where N represents the number of carbon atoms in the molecule. For example, if N equals 2, then there'd be 2 times 2 plus 1 equals 5 hydrogen atoms, giving a molecular formula of C2H5OH. You may also see this written as C2H6O. However, this way of writing the molecule does not show the OH functional group. Alcohols are named based on the number of carbon atoms they contain, similar to alkanes and alkenes, but with the suffix -ol. Methanol is the simplest alcohol with only one carbon atom, which is bonded to 3 hydrogen atoms and an OH group. Its structural formula is CH3OH. Let's try another example. Ethanol has 2 carbon atoms, with one attached to 3 hydrogen atoms and the other attached to only 2 hydrogen atoms and an OH group. It has the structural formula CH3CH2OH. Propanol consists of 3 carbon atoms, with 7 hydrogens bonded to carbons, and with 1 carbon attached to an OH group. There are actually 2 forms of propanol, but for your GCSEs, you only need to know about the form where the OH group is attached to the last carbon. This has the structural formula CH3CH2CH2OH. The final alcohol we will look at is butanol. Butanol consists of 4 carbon atoms with 9 hydrogen atoms attached, and with 1 attached to an OH group. There are also multiple forms of butanol, but for your GCSEs, you only need to know about the form where the OH group is attached to the last carbon. This has the structural formula CH3CH2CH2CH2OH. The physical properties of alcohols can vary widely based on the size and structure of the molecule. Here are some key characteristics. Alcohols exhibit different levels of solubility in water, depending on their size. Smaller alcohols, like methanol and ethanol, are very soluble in water. This means they can mix well with water and form a clear solution. As the size of the alcohol increases, however, its solubility in water decreases. Larger alcohols, such as octanol, do not mix well with water and tend to separate from it. This is because the longer carbon chains in larger alcohols make them less compatible with water. The boiling points of alcohols are generally higher than those of similar-sized alkanes, like ethane or propane. For example, ethanol has a boiling point of about 78.37 degrees Celsius, while ethane boils at -88.6 degrees Celsius. This means that alcohols require more heat to boil than alkanes of comparable size. The presence of the OOH group in alcohols contributes to this difference, making it necessary to add more energy to change alcohols from liquid to gas. Volatility refers to how easily a substance evaporates. Smaller alcohols, such as methanol and ethanol, are more volatile, meaning they can turn into gas quickly at room temperature. This is why you can smell the strong scent of alcohol when it is exposed to air. On the other hand, larger alcohols like butanol are less volatile. They do not evaporate as easily, and you would need to heat them more to see them turn into gas. Although this is a chemical property, It is also worth noting that alcohols are generally more reactive than alkanes because of the presence of the OH group. As a result, alcohols can participate in a variety of chemical reactions, and their unique properties allow them to interact with many different compounds. In our upcoming lessons, we will explore some of these reactions in more detail, helping you understand how alcohols behave in various chemical processes. In today's lesson, we introduced alcohols, a class of organic compounds characterized by the presence of an OH group, often referred to as a hydroxyl group. We explored their general formula CnH2, 8 plus OH, and how alcohols are named based on the number of carbon atoms. We also touched upon their physical properties and reactivity. Understanding alcohols helps us gain a deeper understanding of organic chemistry and prepares us for learning more about their reactions and applications in future lessons. Watch the rest of the GCSE chemistry course at Sophos Education.